Thank you very much for joining us today here. And so Mark Kostras and I decided to do this in kind of a reciprocal manner, so that I would do the introductions today, but the main event is happening in Hamilton, and tomorrow we'll do the reversed organization. So I'm Michael Eickerling. I'm a co-lead of the German-Canadian Materials Acceleration Center. The Canadian co-lead is Mark Kostras. And then we have Andrew Johnson there, and I'm not sure whether Pascal is joining us today, but KIT, so Karlsruhe Institute of Technology, is also part of this and very much involved. So it's Industry Days, that's how we call this event. 2 days, 2 locations, 2 different panels that will be discussing about various topics that are related to this overarching theme that we have in GCMAC. Materials acceleration. So there's one topic that we are going to talk about, and maybe we'll come to some consensus. Maybe we'll find some areas where there is controversy about, let's say, the challenges that we should be taking on. And I'm very much looking forward to these discussions that we are going to have. Industry Days is something that, of course, some of you have almost every day. For us, we are in Forschungszentrum Jülich, so we do research. Of course, we collaborate a lot with partners from industry, but we are also involved in many other aspects of the research landscape. So let's go to the next slide then. Anjali, please, or to the second slide with the agenda so that we can take a brief look at that. Okay. So I would like to welcome, of course, all the attendees, the panelists, and would like to thank those who have helped to organize this event, Anjali Saviola and Kourosh Malek, together with Mark and I. So it has been a little bit of an effort to put this together, but I hope that we'll have very interesting discussions divided up in 2 days, but with a similar agenda on both of these days. So a few opening remarks to put everyone in the picture of what we are about, what is our, let's say, self-defined, self-declared mission that we have with GCMAC, and then give a few aspects to inform you what are our priorities and how we are connected and how what challenges we are taking on. After the opening, we'll go to presentations. So they are called today stimulus talks. Tomorrow we'll have a keynote talk that will be given to basically set the stage. And then we'll go to the panel discussion, and Mark will later on introduce the panelists for today and then also lead the discussion with the panel. The themes you can see here. So MAPS is the short form for materials acceleration platforms. So that's, let's say, one disguise of these self-driving labs that are becoming more and more widespread in the community of materials research, materials development in general, but also in particular in the energy technology domain. We'll talk more generally about what problems are suited for accelerated materials discovery, and that will be the topic today as well, and a topic tomorrow. So next slide, please, Anjali. So what is this GCMAC, German-Canadian Materials Acceleration Center, about? So there's infrastructure, there are competencies, expertise in Germany and Canada, of course, with a focus on energy materials, energy technologies to drive the energy transition, which is kind of a global change that is ongoing. And what we put as, let's say, our objectives is to support technology-focused materials research, to advance method and tool development. So we are application-driven, and that's the first item here. But of course, in order to be able to support these applications and develop new energy materials, bring them or integrate them into the technologies and make them available to the industry, we have to also devise the appropriate methods and develop the tools for that. We want to accelerate discovery, design, and integration of energy materials. So this is not only about, let's say, the design aspect. The integration aspect is something very important. So one, of course, has to be able to assess properties of materials in terms of activity, stability, selectivity, for instance, of electrocatalyst materials, transport properties of porous media, and so on. So we have to assess these properties ex situ, but then we also have to see how they would work when they are integrated into a device, which is a complicated undertaking. And of course, a very important aspect of our mission is also to train the next generation of experts in this particular field at the intersection of artificial intelligence, so in information technology, the materials challenges, method and tool development, as well as the technology development, so bringing these materials online. So we support very much training initiatives and education of the next generation of scientists at the level of PhDs, master's level, but also the postdoctoral level. So individuals who are already at a more advanced career stage, but are looking for the next step to make, and we support them in that. So please, Anjali, the next slide. And of course, this all started because we have common interests. We met, I think, Mark and others, myself, that was about 2019. We got together at an event in Berlin, and there was a panel discussion actually about energy materials. And after that, there was an opportunity to apply for a Helmholtz International Lab, and we tried to seize that opportunity. And in the end, we were successful in securing the funding for this center that we have from the BMBF, so the German Ministry for Research and Education. And of course, what brings us together is let's say, not the funding, but it's the common interests and the shared infrastructures that we have. High performance computing is something very important Forschungszentrum Jülich is heavily invested into, well, staying at the forefront of developments in terms of high performance computing. The first European exascale computer will come to Jülich sometime this year. It will be operational next year. There's a strong investment into quantum computing and trying to find the first applications for quantum computing also in the energy technology domain. AI-enabled materials design is of course an overarching topic. So using artificial intelligence to develop materials, to demonstrate the integration and orchestrate the whole process, the chain of processes that is involved in that. And of course, our partners in Canada have excellent strength in that field, particularly in the AI domain. The robotic and self-driving labs have been demonstrated in many different fields already. The field of energy materials, energy technology is, I would say, a more demanding and challenging one. But we try to bring these methods and tools online here as well. And there's some success, and Mark, I guess, will be talking about this. But of course, there's also a need to determine where are the main challenges and where are the big opportunities for us to go after. Next slide, please, Anjali. And so here is how, let's say, we are set up in terms of the methodical competencies. So we have the work packages that you see here. Theory and modeling is, let's say, the underpinning for our efforts, AI-driven design and simulations. So to establish, let's say, the foundation for bringing new materials acceleration platforms, self-driving labs, modern lab structures online. Autonomous robotic maps, so that's work package 2, and characterization and fabrication, work package 4. Those are the 2 work packages that are coordinated out of the Canadian partner labs. And then the whole thing is orchestrated in work package 5 by the AI-enabled data handling and workflow optimization. So that creates knowledge, it creates data. The data is basically fed into an orchestration unit that is using AI, artificial intelligence, to coordinate the processes, to perform the analytics and feedback information or results to the various materials labs that we are connected with. So we have associated experts who can manufacture, who can design, and who can perform ex situ characterization of materials. What is involved, I mentioned that already, the high-performance computing side is a very important aspect for us, and the development of the hardware platform, which is the materials acceleration platform. Next slide, please, Anjali. So here's a range of materials that we are looking at. So electrocatalyst materials, ionic media. Of course, these materials are not functioning alone. They have to be combined to form interfaces and electrodes, complex electrodes, which are also porous media. So we look at porous transport media. And then these different materials components and functional components have to be assembled into a device that can perform the function that is needed in a fuel cell or from a fuel cell, or in water electrolysis, CO2 reduction cells, and so on. So if you look at the next slide, then we see how methodical competencies are integrated with those along these different scales. So there's scale-to-scale integration that you see on the horizontal axis here, as well as component-to-component integration, going from elemental materials and components to the full device, and integrating along the verticals the various competencies that we have in the different work packages, as mentioned. So next slide, please, Anjali. Of course, the, let's say, opportunity for something like this is not equally distributed among the different technologies that we have in our focus. So there are certain technologies, well, we know, or we expect them to have a high socioeconomic impact ultimately, and there's a huge interest in them, but maybe they are at this point too complex to tackle with some of these tools that we are developing. But maybe there's a strong need and there's a strong drive that must also come then, of course, from industry, that we should be developing this, and that we should harness the artificial intelligence-based infrastructures, this orchestration that I mentioned before, to, let's say, advance them from a relatively low maturity level along the horizontal axis here to a more advanced maturity level. Of course, we are driven by applications, so there are certain needs to bring online new technologies, make them or advance them to a stage where they can be commercialized at a large scale. So that might be the driver. So then, of course, well, we need to invest a lot into the research to develop those technologies and bring them to that maturity level. So now the modern lab concepts that I mentioned before have certain requirements in terms of infrastructure competency and so on. And so typically, let's say, if you look at the university landscape, the landscape of publicly funded research institutions like ours, there are certain labs that focus on the modeling and the data side. There are certain labs that have ability maybe to do prototyping and scale up. Other labs have all the characterization tools, or maybe part of the characterization tools. And so these might be dispersed over many different labs and so on. So, of course, communication becomes a very important aspect. And if that is not happening, the whole process will be rather ineffective. So on the next slide, then we see, or the next, let's say, variant of this slide, we see that all of this must be integrated. So we need all of this, and all of this is already available, but maybe it's not connected in a way that leads to the most efficient outcomes. And so this is the kind of orchestration that ultimately we try to provide. And so GCMAC is one of our conduits to go after this challenge. And of course, there are other projects that we have on the German and Canadian side, and we try to coordinate as much as possible on these. And so this would be my general introduction. And now I would hand over to Mark to basically introduce and lead through the program that we have for today.
Thanks very much, Michael. There's always information that I learn even as I go after 5 years of looking at slides. You presented some great information there. Today, for Industry Days, day one, I guess our objectives really look like this. First of all, it's to introduce and connect the GCMAC researchers, us, to German and Canadian companies, and with academia as well. But the focus today is to really engage with industry in presenting the information that we're going to hear, to be aware of accelerated materials discovery. And that's so that we can generate awareness of what we're doing. The ecosystem is growing very rapidly. And as a result, raising awareness and creating opportunities for collaboration between the three partners, government, industry, and academia, is critically important. And our theme, of course, is accelerated materials discovery, but integration for energy applications. So we're still on the energy file here. We realize there's other sectors that could benefit, but our focus in Industry Days today is on the energy applications. And then to develop strategic initiatives that more broadly support accelerated materials discovery. So we have a good cross-section of industry players in today's event, but we want to also include some of our government colleagues so that we can talk about the things that we're working on, that we're doing, to be able to enable greater penetration of accelerated materials discovery. And then, of course, we also have Jay Myers from Engine, the supercluster in Canada, who's going to help us look at the different organizations. We also have Ura AG, who has many technology clients in Europe. So they're involved in this activity as well. So really, it's a deep penetration of the ecosystem, raising the awareness. Next slide, please. So framing the day. How is the rest of the session going to look? First of all, we're going to highlight early industry engagement and accelerated materials discovery. And that's going to be through stimulus talks. We decided that it would be important to have some people from the ecosystem telling us about their interests, why they wanted to look at accelerated materials discovery, maps, self-driving labs, and really hear from them. Perhaps we'll hear some provocative things that of what they need. So we're going to promote the concept of self-driving and autonomous labs for energy applications. As Michael said, we're just getting started with that, but we've got a critical mass, I believe, now. So this event is the right time to do this. And understand the industry interests and needs related to accelerated materials discovery. Then promote awareness and opportunities, perhaps from opportunities that government investments are creating to be able to extend exchange, training, collaboration. And finally, identify emerging areas of interest. One of the things that we've done over the last few years is really try to understand what are those topics, what are those sectors that would benefit from this, and then learn and plan for the future so that we know what to invest in. So thanks very much. Welcome to Industry Days, day one, and I'll pass it over to Angelique.
Thank you so much, Mark. So now we'll hand things over, as Mark mentioned, for our stimulus talks. So we'll begin with, we have 4 speakers today, as you can see. We have Jason Myers, CEO of Next Generation Manufacturing Canada. We have Khalid from LabsQ. And we have Errol from BC Research, and Curtis Brilliant from Miro. So we'll begin with Jason Myers with some for his stimulus talk. So over to you, Jason.
Yeah, thanks very much, Angela. I hope I can be stimulating this morning or today in the afternoon for those German colleagues. Next Generation Manufacturing Canada is the organization that I run. It's a not-for-profit organization, really focusing on 2 things. One is identifying and connecting and building collaboration across advanced manufacturing ecosystems, not only in Canada, but globally. Secondly, then providing financial support for collaborative projects that were really transformative and that have significant commercial potential. So later stage technology readiness projects really focusing on the scale up, the demonstration, and the application of technology solutions in industry. One thing that we've discovered as a result of our work in doing that, in particular funding transformative projects for industry, is that technologies cannot be considered on their own, that they're part of, not only in many cases, part of an integrated industrial solution that industry needs to be able to adopt readily and be able to manage it in a cost-effective way. It's not only a matter of integrating the technology, but it's also making sure that the use of technology delivers real business objectives. And if you look at most of consulting reports around digital transformation in industry, they all conclude that something like 70 to 80% of digital transformation projects fail. And the work that we've done here in Canada, particularly in small companies, shows that even not looking at systemic transformation, but the number of companies that invest in new technologies, about a half actually achieve their business objectives. 35% say they don't, and 15% say they don't know, which tells me they might not have business objectives in the first place. We don't know what the business objectives actually are. So, I think my main message here is that perhaps maps aren't for every purpose, There's huge technology promise and opportunity with maps, but they need to be managed well. They need to be integrated in a way that businesses can see where they're going and how to use these to achieve their business objectives. They need to be, of course, supported with the right data, data infrastructure in order to make this work. And of course, a lot of that has to be driven by just the simple question of how to deliver greater value for customers at the end of the day. Now, having said that, there are all sorts of opportunities, and this is why we're actually very, very interested in maps. I'll talk about the bigger opportunity, then I'll talk about how Mark introduced me in the first place to this great opportunity here. The business, manufacturing is changing rapidly. Advanced manufacturing is changing rapidly. Here, changing customer expectations, changing regulatory expectations and requirements. Of course, to greater sustainability is also extremely important and at the core of what the discussions will be about around energy materials, the use of maps to develop, to characterize, develop applications for energy materials here. So I think there's a growing requirement by industry here. It's also, this is one of an example of an advanced solution in an industry that drives all sorts of other improvements. You can't develop a new material without also thinking about how that's going to change process, what sort of data requirements you need, how you're collecting the data right now, and then what you need to do to actually be able to support a technology that is actually working for you. So it's driving improvement throughout industry. It's certainly also helping many companies achieve what their goals are in terms of being able to match consumer or customer needs and to be on the lead in terms of differentiating themselves as a solution provider around sustainability. So those are all very, very important issues for us. The other reason I'm interested in maps is purely a personal reason, and that's because Mark introduced me to this great platform in 2018, 2019, when it's getting off the ground. And so been very happy to support the efforts here at CanMet and at U of T and at UBC as well. I remember before COVID attending a venture capital conference in Vancouver, where a major investor from Japan was talking about they were focusing on developing a rapid materials, AI-enabled materials characterization and testing platform. They thought this would be the first in the world, and that it would take them 3 years to do it, but watch out because the Japanese were well ahead on this. And I was on the same panel with him. I mentioned that maybe you should walk up the road to UBC and see this already at work there. So that was another great opportunity, not only to showcase what Canadian capability actually is, but also to validate, I think, the importance of what this is all about. Let me I mentioned some of the issues around how to integrate, or the challenges integrating with industry. I think there's an awful lot more interest, and we were speaking just before the panel started, on the part of industry about AI solutions and materials discovery. Here, I think certainly it is an important solution for many companies. It's not a solution for everybody. Here, I think one of the challenges will be there's going to be a great amount of industry interest, and then the issue will be how to actually integrate it well in business. Talked about this before. How does this support business objectives? What are the business requirements for successful implementation of these systems in a business. You have the skill sets, you have the data, you have the computing power, you have the partners in place to support it here. So we're not only providing funding for projects and to bring together the ecosystem, but we're also spending an awful lot of time speaking with companies about basically about best practices in innovation management, which not just in terms of maps, but goes well beyond that in terms of the adoption of other digital systems here. So I think Mark, that kind of covers everything. The one question: how do we work together more with academia and government? I think that's really important. I think here in Canada, in my experience, particularly around maps, here's a great asset, and it's lacking one very important thing, and that is that many people do not know that it's there here. So this is one way that we've supported the whole platform, just drawing attention on part of industry, but also on the part of government to this. We're at the end of the month, Canadian government, German government are getting together in a joint science technology investment conference here, and this is not on the agenda. I don't know why, because there's a great deal of discussion going on around climate change here. I'm not sure if people in government know about the opportunity. I think more people probably in industry know, and the funding that has been made available for the labs here certainly has heightened industry attention around this. But I think we need to be able to, as Mark said, really work on this, not as individual sectors of government or silos within government and different labs working separately and industry one by one. They're really coming together and seeing this as an extremely important tool that addresses big challenges for industry, that brings academic labs together around industry needs, and that also supports the policy priorities of both of our governments here. And I think we have a lot of work to do to make that happen. One further thing is that we do have funding, and we would be glad to continue. And Mark and I have already been chatting about how can we continue to support that integration of industry, academia, and government. And I think there are two opportunities. One is that we do provide financial support for collaborative projects in which maps may play a really important role here, and can do that for Canadian companies, and those projects are open for German participation as well, although the German company need their own to bring their own funding along with it. That's one opportunity, but the other opportunity is just simply, and I'll throw this open to participants, is there an interest in putting together an industry academic cluster around advanced materials and materials discovery, particularly energy materials? We're going to be over the next year launching two funding programs and funding streams that are going to be particularly important for maps. One is in the area of materials for electric vehicles. The other is in the area of decarbonization and circular manufacturing. So I think both of those project areas would be key. But as I said, we're also in game of funding the development of ecosystems here too. So that's another opportunity. Thanks.
Great. So thank you so much, Jay, for those remarks. That was quite insightful, and I think gives us a lot to think about going forward. So next we'll hand things over to Ira, who is joining us online bright and early in British Columbia. So Ira, are you able to come online? And if you have any slides that you'd like to share, please feel free to share them from your side.
Thanks, Anjali. I'm trying to screen share here. Is that visible? Are you able to see that?
Yep, please go
Yes.
right ahead.
Well, hello, folks, and greetings from Vancouver on the West Coast, where the sun has just come up. I'm Ira Wolf. I'm with the NORAM group of companies, and wearing my BC Research hat. BC Research is a wholly owned subsidiary of the NORAM group. We are based primarily here in Vancouver, but also have offices in Gothenburg, Sweden. The NORAM group of companies is a fairly tightly integrated portfolio of companies. Technology companies associated with the scale-up and commercialization of novel technologies. Right in the bottom right there is the latest addition to the NORAM stable, NORAM Electrolysis Systems, or NESI. And right from the get-go, NESI has been faced with this conundrum of materials or critical materials. NESI is focused on the electrochemical production of lithium hydroxide for the lithium-ion battery market. And various elements of NESI are very much caught between this rock and a hard place. The ion exchange membranes are based on the industry standard of Nafion, which is coming under increasing environmental scrutiny. And is difficult to imagine a successor, a system of materials. The elements are coated with mixtures of platinum group metal oxides like iridium and ruthenium. Again, a critical resource, and very often in quoting to our clients the cost of a cell house, we have to hedge because when we deliver these cell houses 2 years down the road, we don't know what the price of ruthenium and iridium is going to be doing at that time. BC Research is a pilot plant facility here in Vancouver. It accelerates the commercialization process of novel chemical and process technologies. And it typically builds skids and pilot plants and runs them in a plug-and-play space here in Richmond, near Vancouver. One of the areas that we are concerned with, which brings us to the topic of today's conversation, are palladium membranes. And in 1998, NORAM became an investor in a company called Membrane Reactor Technologies. And that was focused on the use of palladium membranes to separate out hydrogen, specifically at high temperatures in membrane reactors. And this work proceeded until about 2016, at which point we acquired the assets of MRT and continued to develop these palladium membrane systems. At that time, I think MRT could claim to be the world benchmark or the world standard in what had been achieved in palladium membrane separation. It had developed the most effective, most long-lasting, and also the most economical metallic membranes for hydrogen separation. This is a compelling market. The entire hydrogen economy is predicated on being able to separate out hydrogen. Whether you are electrolyzing water or reforming natural gas or reforming ammonia, the hydrogen has to be separated out from a complicated gaseous mixture. So the market is large and it's compelling. Its competition are capital intensive, mechanically complex pieces of equipment, such as pressure swing absorption. And they also suffer from the inability to go after hydrogen at these very high temperatures that we need in the reactors. Over the course of the years, we have built a number of these prototype systems, supplying companies around the world in Italy and Japan, and most recently in Australia. We have set sights on developing hydrogen from ammonia. And most of these reactors incorporate this palladium-based system in some form. We can imagine it as a thin foil, maybe as thin as 4 microns up to anything like 20 or 25 microns. It could be a plated coating in a tubular form. And the manufacturing process is fairly complicated. It might involve a number of different materials, including diffusion barriers. It needs a composite structure for mechanical support. It needs means of sealing the hydrogen, and it requires performance at very arduous temperatures and gas compositions. At the end of this time, and we're talking about 20 years of consistent development work and pushing this technology forward, we can conclude that these membrane reactors work very well. They are stable, they are predictable, they are an excellent way of producing hydrogen. In particular, they lend themselves to the production of high purity hydrogen using these metallic membranes. The membranes work like a son of a gun. Unfortunately, they don't last very long. And we can measure that stability in terms of maybe months of operation rather than years. And also within the hydrogen economy, the demand for high purity hydrogen has become more insistent, and it has become more important to develop membranes that are capable of producing something like 4 or 5 nines hydrogen. On the screen there is a whole litany of ways that these membranes might fail, through interdiffusivity, through defects, through contamination, through segregation of the hydrogen. An improvement in any one, any one of those failure mechanisms would extend membrane life, would represent money in the bank, as it were. What we're looking for are cheap or cost-effective replacements for the existing state-of-the-art. We need them to last longer. We need them to be not material constrained. And we may well be looking in completely different material systems or manufacturing routes to get there. At which point, NORAM and BC Research got drawn into the MAP philosophy. Because we are faced by a very large experimental space, very tedious experimental times, and very poor predictors of the systems that we choose as to what their performance is going to be like. In accelerated materials discovery, we are shown something of a promised land. We've discovered over the course of 20 years of development that progress is only as good as the amount of effort we put into it. If we put 2 scientists on the job, well, then we get double the amount of progress and output. But it's a very linear progress. In materials accelerated or accelerated materials discovery, we have the option for the first time of contemplating an exponential rate of discovery and development. Perhaps more importantly, everything we do is very predictable. We only know what we know. And every time we come up with a new candidate system, it's really based on our knowledge or experience of what we experienced with previous systems, we aren't thinking outside the box. It's a question of where do you go looking for truly novel systems. And then, as I said at the outset, the membrane technology is a compelling one for us, but it's also highlighted to all of us within the NORAM group of companies that there are a whole bunch of enabling technologies which might benefit from an accelerated discovery program. The electrochemical one is a good case in point. It suffers from a number of material vulnerabilities in the marketplace and could benefit from a larger vault of materials to pull from. Finally, we come to NRCan here in Canada and MAP, and the realization that with the best will in the world, we can't go from 0 to 1 overnight. I think for the very first time as a materials scientist myself, I find myself in a cosmos where no single person knows everything. This is a exemplary example of an interdisciplinary effort. We are not capable of putting all the mechatronics or AI and machine learning people or modelers around the table, even within the NORAM group of companies. It would take us a very long time to get to that capacity. And so the NRCan MAP platform that we've been introduced to here in Canada gives us a bit of a leg up and a starting point in that the development exercises within our company have a number of good interfaces with what is already happening on the MAP front, and would be a non-starter for us if we had to reinvent that wheel for ourselves. I hope I didn't exceed my time, and I hope that was a useful overview of where MAP fits into our universe. We have only been initiates for perhaps a year or so now, and are looking to gradually get our feet wetter, and look forward to developing this discussion with our colleagues around this table today. Thanks very much.
Thank you so much, Ira. That was very informative on the work that you're doing over at PC Research. And now we'll hand things over to Khaled, who's here in person. And I'll share your slides now for that.
All right. Hi, everyone. Thank you for having me. I hope you can all hear me. So I'm going to talk a little bit about kind of creating a lab in the future. We work mostly in the polymer space, and I'll get into that. So a little bit about me. I don't know why I saw this picture of having a tree play. My name is Khaled. We started the company about 7 years ago here in Kitchener, just down the road. It came out of my master's. So I was doing a master's in adhesive development and material development. I hated sitting in a lab after testing 1,000 samples over and over. And it kind of started from the realization that making materials is a really difficult process. Now, 7 years ago, we effectively drew up some concept that looked like a map. And we went out there and kind of talked to investors and customers and industry, and no one was willing to pay for it, right? It was too academic, it was too new, it was too different. And I think it was a very complex project with a lot of technical hurdles. And so we kind of had to take a step back and figure out where our company was going to fit in that process. What could we do today to start making an impact with companies, with industry? What improvements can we make to start moving slowly towards that goal of building this big map audacious plan? Like that. So we started the company, and effectively we started with building equipment where we can improve their testing processes today that they do in their lives. Specifically rubber, plastics industries, some adhesive industries now. Really, we looked at their high volume tests, the things that they do every day, And we said, can we build automated systems that are easy and affordable effectively to start plugging them in? And to just get them used to bringing in automation as part of their process. Where before everything was very manual, you guys have labs, you've seen endless amounts of labs. Some of the most sophisticated labs out there in terms of the big companies, the 3Ms, the BASFs of the world, et cetera, are still very manual. They still have technicians sitting there doing the same thing over and over. And so our hypothesis, our thesis was, we'll start with something that we can directly impact and make a positive impact on them. And this will be also a piece that moves us towards starting to collect good data, clean data, and building maps with them over time. So this is our little Trojan horse for that concept. So this is just a quick video of the current machines that we have. They're bigger than they look in images. I don't know why. I think I should lay down beside them or something to give an idea of size, but they're about 200-pound systems. We looked at standardized tests. So people are doing very standard tests in all these labs around the world. We took those standards and we effectively built them into automated enclosed boxes. And through that process, we built a lot of tech know-how, we built a lot of connections. These systems are now out in production. Customers have them sitting in their facilities. Some customers you might know, like Bridgestone, for example, has these systems, large and small companies alike. And we've been kind of deploying them and they've been in production for a couple of years now. So I think our implementation and our path towards building the concept of a map. Again, when we started, we had no idea it was called a map. I think when I first connected with Mark and connected with some other people, and I learned about the map concept, it was like I finally felt like I wasn't alone. Forever, I felt like I was drumming, like I was on this island talking about this thing that I thought was kind of out there and too academic, and there was just no other support around it. So when I found that, I was a bit surprised, shocked, and happy all at the same time. In terms of that, but our thought was essentially we started around rubber. Again, that was just more from a resource point of view. You start out small, you start out niche, you figure out something where you can make an impact. We've now progressed up into plastics and adhesives. This is where, much larger market, obviously a lot of impact around that. And then now we're starting to look at, we built up this tech stack around automation, we have great data analysis teams. Now we want to start moving towards a map. We had a couple of ideas for where to build a first map or potential of where we can make an impact and showcase it. So that and this is purely from talking to industry. So for me, it always goes back to, I talk to our customers and I want to understand their problems. As much as I love the academic side of things, for me, it's like, where can we make an impact today or as soon as possible? And I think like Jason said, the problem that you find in the industrial side of things is they want things done yesterday. And when the hype cycle happens, like right now we're seeing a hype cycle around AI, management will come along and put money into it initially. But when they don't see enough of a movement in 6 months, 12 months, they'll drop it. Just like sustainability has gone up and down over the last 10 or 15 years, and every company talks about it only when it's high. So I think it's always important to keep that in mind when talking with industries, like how can we make an impact and how can we show them the positive to them? So yeah, we talked to them and we essentially realized there's probably multiple places where a map can fit around the polymer space again. There's the quality side. They care about production. If you can improve production in any way and improve the material they produce and make it faster and cheaper, they're willing to pay for it. You can do it on the R&D side. So if they can do faster than their competitors, produce better materials that are cleaner or cheaper or whatever it is, they're willing to pay for that. And then the other one that we found that really started to hit home was around the sustainability and the plastic side. Now, I think it's just right now because it's a good buzzword around sustainability, they're willing to put money into it. So I think that's why we can showcase the map in this first thing, but really this map could be across the board. But this is just a great place to start. So we called it the cube. I think there's something else called the cube now, which I didn't realize that because Steve Jobs when he created that other thing, I think he called it the cube. So I might have to change that. But effectively, our concept around the cube is fully automated lab testing or lab development for polymers, so for plastics specifically. We talked to a lot of people when it came to why are you not using more recycled plastics? What are the hurdles that you see in terms of using recycled plastics? And it'll always come down to two things: it's consistency and cost. Really, it's going to be cost is the big one. Companies will not pay more just to be more sustainable unless governments push them. In the end, they have a margin and they need to hit that margin and they need to make profits. That's the reality of it. That's the systems we have built up. So we started looking at the recycling plastic process and how can we potentially put in a map or improve that process by adding. So one of our thoughts is by looking at mechanical recycling and the process of mechanical recycling. Currently, one of the issues is you have an unknown set of material that's constantly coming to your plant every day. So how do you guarantee successful or great outcome? So we think a map is kind of the perfect thing right in the middle of this and make a huge impact. And it's really kind of, and customers are really excited. And this is for me the most important thing where I can get industry to jump in, the large companies to jump in and be part of these projects. I think that's what's exciting. So our path that we have at least mapped out to a certain extent right now is we're starting with an IRAP project. That IRAP project has already started and we're building out one piece of the map where our expertise really lies around the automation of the testing piece and building out all the important automated testing tools that are needed. We want to showcase this to people as a good demonstration, get people excited. And then as we kind of move forward, the next step will be to kind of start engaging. So we have SDTC, and we've engaged them in certain project, in this project as well. Obviously, Engine will potentially be there. And then there's a lot of the corporate partners. To me, corporate partners will always come first, and then I'll kind of layer everything else in because it has to be industry good. I just want to make sure that's kind of the main thing that we're focused on. So I think the next step would be building something more feasible around kind of a new plans. And then lastly, is trying to figure out how do we actually take this to something that can be commercialized, and what is that commercialization path? And I think there's multiple different ways that we can go. Before I kind of finish, I want to there's a couple points that I think, number one, what do we need help with? Obviously, all these maps projects are very audacious and big, and they require multidisciplinary teams that have, so there's great AI people out there. I'm not going to hire and build an AI team. I don't think that makes sense. It's better to team up with people. There's funding as part of it. Industry is excited, but they're also not willing to foot the bill completely. They never are for a purely R&D projects to begin with. So there's got to be government and there's got to be like large incentives around that coming into it. So I think that's kind of one thing is how do we all work together to build towards these things? What are the different tools that are out there that are already built? I don't want to rebuild things. There's no point of rebuilding or going through that process. So I think that's kind of important. The other one I want to say is the last 6 months, as ChatGPT obviously is the main thing that everyone talks about, but I go around and give talks to rubber and plastics conferences in the industry. And I do it almost twice, 3 times a month kind of thing. And in the last 6 months, I've seen a huge uptake in kind of people talking about AI and trying to actually implement it. So I think now is the time to really capitalize, jump in at 100% because companies are there. Management is asking, where's our AI strategy? How are we implementing it? So right now is the time that industry is willing to actually be part of the conversation. So I think it's a really great time to jump in. And I know like Toronto just got 200 million or whatever, or that whole consortium. So there's a lot of money also flowing around. And that's in the end, we need that resource. But I think industry is there and ready to go as well. Thank you so much, everyone. For my contact info.
Thank you so much, Khaled, for sharing about Lapspeed's journey and your focus these days. So that's super interesting to hear.
Yeah, thanks very much to the speakers. I have to say, even though I've been involved in talking with all of you over the years, I think Khaled, you said for years, and Jason as well, many years of our discussions, there's some really, really important things that are evolving now. And I think the opportunities really do present themselves because we pull together things like this that will get us coordinated. And so thanks very much for all those insights. I learned many things as well along the way. Curtis, fantastic that you had the map actually impact on something that's going into production. It's inspiring for all of us. We're going to move now to the panel discussion session. And the way that we're going to approach it is that we have 4 panel members. Curtis is going to rejoin us as well for the panel. But 4 panel members, we will present, we'll let them introduce themselves so that we get a picture of it. We've got a slide that gives a little bit of information that you'll see that has contact information if you want to jot it down, etc. And then we'll move into the more formal side of the panel. So next slide, please. At this point, I'd like to invite Stephen Carlson to join us on screen. Stephen?
Okay, yeah, just trying to get unmuted here. Can you hear me?
I hear you now.
Okay. Yeah, I'm with a company, a Canadian company called Meta Materials. We're headquartered in Halifax, Nova Scotia. We have a very large laboratory there. And we also have operations in the Ottawa area in Thurso, where we have a metallizing manufacturing plant. And we also have a large operation in the Vancouver area in Barnaby, which does kind of nano patterned security markings for banknotes and so forth. And then I'm with the group that's in the Boston area in the US, and we work in the battery products area, basically on the separator, which is the porous membrane that goes in the insulating area of the battery. And we have a sister group that's in Oxford, UK, called Plasma Apps, that does all kinds of metallizing. And I really appreciate the talks that were just given. Were very fascinating, very, very interesting. Obviously, I mean, our Plasma Apps group, for example, can plasma deposit any material on any substrate. So you could just see how you could have a lot of interesting things doing accelerated development of materials with that kind of flexibility. My own background, I'm basically an organic chemist, and I've been in the coatings business for actually over 50 years now. And I've been involved in a number of different industries. And once again, this whole concept of accelerated materials development is very fascinating. One thing I've learned in business over many years is the best materials win. And that's a key point. And just one last comment on metamaterials. We're into materials that are really unique. Some of them are really on a nanoscale, so you get properties that you just cannot get on a micro scale. Other times it's materials that have some kind of a unique optical property that that other materials don't have, and therefore they have an advantage. So that's where metamaterials are, these unique properties, and obviously it lends itself to your accelerated materials development because you screen a lot of materials and you find certain things are unique, and you just can't make certain products without those more unique materials. So I'll stop at this point, and so we can go on from here. If I can make a few comments here, I'm coming from almost an entirely different background since I've been in industry really since 1969, kind of old style, you might say. What you kind of summarize, now that I can look back over the years, what basically, I didn't have any of these rapid accelerated techniques. So we were, like I say, old style. But over the years, actually starting in grad school, but over the years, I would come across certain materials and I got to understand their properties. An example would be stable free radicals that have really unusual index refraction properties. Another one was sol gel coatings, which I never heard of for, until the early 1990s. I got involved in them in the inkjet receiving sheet business. And it turns out, then recognize the properties there. And then I get into another application and I could see right away that that technology would have an application there. But back to what you're doing, I'm kind of in favor of basically a hybrid approach where you have all your accelerated methods make a lot of sense and certainly would accelerate some of the things that we're doing right now. And I look forward to collaborating with some of the speakers that I've heard today. On the other hand, I think there's still a place for kind of the individual creativity. I tell my people lots of times, if you spent the whole day just thinking about your problem in your office with no distractions, that could be the best output that you would have on a given day, just the individual thinking and so forth. Another thing that I'll mention quickly that I'm come to appreciate more and more is it's very important doing these things, because basically the accelerated materials development is trying to accelerate inventiveness and creativity. You definitely want to have a good patent strategy, because in this world, if you don't patent it, you're going to lose it to someone else. And so you want to, and it's a first to file world. I won't get into the details there, but I'm saying that understanding the prior art that exists on what you're doing and the state of the art, and then whenever you do have an invention, getting something on file, and people basically now do a provisional patent, which is easy to do in different countries. Then you have a year to do a regular application that goes for 20 years. That's an absolute necessity, and that gets you to do a lot of thinking. And then the kinds of things we're talking about here, the accelerated materials development, is twofold. One, you might use that to actually make a new discovery, or like in our case, we have, what strikes me from the very first time I heard about this approach is we have patents that are like battery separators that are 50% porous membranes that comprise any organic carbonate bonded to a certain type of aluminum oxide. You could do fantastic screening of all the available organic carbonates just to optimize it for certain performance properties. It's exactly the kinds of things I think or have been discussed here, those types of things. So it's almost like use your accelerated to find some inventions. If you have a really broad invention, use it to optimize the choice of materials. And I think we heard about some of that today. So I'm just basically saying I really see the value of a hybrid thing. And one last comment. One thing, I spent 1 decade working in Silicon Valley, which is the most highly networked, collaborative type environment. It's just kind of almost the atmosphere there. And I think that's what we're talking about here, is a lot more collaboration and then combined with these accelerated methods. So I think this is very good, because then your collaborations are on an accelerated scope, and that can be particularly, more advances. And just one last comment, in the battery area, there's a company in California called Wildcat Discovery that's been doing these accelerated methods for over 10 years and basically trying to find better battery materials. So that's an example of an established organization in the battery business that has been successful. So I'll stop at this point.
Yeah, thanks, Stephen. And Curtis, there's a couple of things that you said that are fairly important. Curtis, you mentioned that we're pioneers in this area. And of course, the pioneers are going to have to bear the brunt of the cost. But that means that there's within the collaborative system, Stephen, that you just mentioned, within that collaborative system, we have to find ways to support the kinds of activities that you are looking at, whether it be the automation, the mechatronics, whether it be the AI, ML. And I think within government, we do have a role in this area. And Jennifer, and what are your thoughts on how we can step in to be able to move that dial forward in this pioneering effort?
Thanks, Mark. I don't know, Jennifer, go first, or we can go first?
You go ahead. I think you can probably speak to that particular question more appropriately than me at this point. Thanks, Andrew.
It's really interesting. I mean, I prepare my own notes in response to these questions, and I think that we're going back to similar themes here, and it's interesting to see the synergy here in the thinking. Collaboration is absolutely fundamental in this space. But interestingly enough, I love what Steve mentioned about you must have an IP strategy. So you have an IP strategy that is developed in the consideration of the fact that some of the things we're going to have to do here are going to have to be open source effectively. They're going to have to be foundational capabilities that we're going to have to pitch in with probably materials databases, a lot of things in collaboration. But the end result is people have to make money. So you're going to have to think very carefully about what you do in collaboration and what you then are going to take under your own hood and you're going to do in your own organization. And I think for organizations like NRC, we have multiple roles in this sort of thing. One of which, through the IRAP, Industrial Research Assistance Program, of course, is on the funding side. Now, it's a specific part of the funding ecosystem, so it's for SMEs, but a lot of our organizations in this space are SMEs. And of course, a lot of the value chain is in SMEs, and I know we get just Labs Q mentioned their IRAP funded at some point. We also have the funding that we had with the Materials for Clean Fuels program, and the other similar programs that perhaps Jennifer can mention when she gets to her talk. There are one is coming up in battery materials. That is another example where we're going to be working with industry, academia, and NRC to do joint initiatives. And of course, with the by being a convener at places like the NRC Mississauga, and with, I should say, I call it NRC Mississauga, but just one thing I want to emphasize here, this is really a collaborative space in itself. The building itself, the facility itself is a multi-institution facility, NRC, NRCan, and as we evolve, hopefully a lot of other organizations will physically be engaged in that site. So we hope to be literally a convener of people in the same physical space and support collaboration by bringing people together physically, and of course through supporting financial support as well. Although I have to admit, NRC is not likely to be your primary supporter itself, but we will help provide access to that sort of thing.
Yeah, and I think the access to the facility,
Oh, yes.
once it's up and running in its full capacity,
Yeah.
is an important part of supporting things, Curtis, that you talked about, which is the pioneering stuff. We'll have assets that can help industrial players realize maps faster. And in fact, that's what we talked about with Khaled at Labs Q as well. Jennifer, did you have anything to add on that side of thing? Some of the access related stuff or support related stuff that might help the pioneers move forward?
No, well, thank you, Andrew. I think that was a really great summary. Maybe I would just take this opportunity to explain a little bit about the National Research Council of Canada, which is the NRC acronym. Of course, NRCan is Natural Resources Canada, and these two federal government agencies in Canada work very closely together. The National Research Council of Canada is a federal laboratory with three main mandates, three main goals. One is to perform research and development to generate knowledge. Another is to act on Canadian federal government policy and help support that policy with evidence-based decision-making. And the third mandate is to support business innovation. So the two main parts of the NRC is the laboratory that we do have laboratories all across Canada with almost 3,000 researchers and technical staff. And then the other main part of the NRC is the Industrial Research Assistance Program, which we call IRAP. And I think some of you have mentioned IRAP already. And the IRAP offers funding to SMEs. And I guess if they put up the slides, there's a little bit of technical information about IRAP. Now, National Research Council has identified Germany as one of our priority economies, and federal government works very closely with Germany, and NRC works together with the German Federal Ministry for Education and Research, the BMBF. We have a 3+2 call for proposals. We've had two of these calls in the past few years. The first one was on AI and advanced manufacturing, and we heard a project today. Actually, the project about the electrochromic windows was supported through one of the 3+2 funding calls. The 3+2 configuration is an SME in Canada a Canadian academic institution and an NRC component. And the two parties in Germany are a German SME and a German laboratory. And as an opportunity that's coming up in future, the NRC and BMBF are discussing a subsequent 3+2 call, and we're hoping to have an announcement for when that would come out in the near future. Speaking about the IRAP, the Industrial Research Assistance Program, there is opportunities for Canada, Germany to work together. The German ZIM program is entirely analogous to the Canadian IRAP program. There are joint funding calls between IRAP and ZIM 2 times per year. There's a call, I think that's either closing soon or has just closed. So the next call will be in approximately 6 months' time. And I would invite everyone to have a look at the IRAP International website. Both the 3+2 and the IRAP ZIM joint calls are announced on the IRAP International website. So it's easy to go find out when the next call is coming up. Perhaps at this point, I'd also take a moment to say a little bit about the Canada-Germany Science and Technology Cooperation Treaty. Someone earlier in the program mentioned about a joint Canada-Germany investment meeting. I'm not aware of an investment meeting, but there will be a Treaty Commission meeting at the end of May. And even though I can't say very much detailed about the agenda, I can say that green energy is certainly on the agenda for Canada-Germany. And there will be some discussions of including some of the departments and agencies that are present at this event today. And we're really doing our best to make sure that these types of topics are included in these coordination meetings. Both Canada and Germany have invested in this GCMAC platform and are very excited about the types of results and hoping to do the best we can to continue with that. I think perhaps I'll stop there, and I'm very happy to answer any questions.
Yeah, what I think we'll do is I want to maybe follow on and just speak to the point about Stephen Carlson, your comment about individual creativity being unlocked. And the question that I have around that is that how can our facilities, say for instance, the NRCan, NRC facilities, help to get you and your people, your researchers, time to be able to explore their creativity? How do we, what do we do? And Curtis, how would we support Mirrors in their ventures by making facilities and expertise available to you, so that these people that are the experts that we don't want to lock out of the picture actually consider creative things, more creative things? Stephen, any thoughts?
Okay, well, I think just to pick up where I was speaking before, I can't emphasize too much keeping aware of your patent strategy. When you get kind of the broad idea that's, could be, very important in a certain area, you want to get that filed and so forth. And then there's a lot of, improvement patents from there. I think what I'm actually kind of relates to your question. One of our advantages that we always try to do as much as we can on the patent side internally before we get out interacting with other organizations. And it's almost a protection to other organizations that if something is patentable, that it's kind of in the system, first to file type system. And then you can work openly with people and collaborate. And I think that goes back to your question. For example, our specialties are mainly porous membranes that are about 50% porous, so we can make them 60% or 40% or whatever. And we have a lot of flexibility in what we do there. And we have that really well patented. So we're very interested to work and collaborate with people in kind of win-win relationships, and that would relate to the accelerated work that you're talking about. For example, a lot of our stuff is because our membranes are 50% air, and we're trying to get them to have as much mechanical strength as possible, especially like in the battery area. The way they assemble the cells is so high speed, and they use the porous membrane is the one they use to be the strong component. So what Caleb mentioned on having an automatic way to measure basically stress strain curves and stuff like that, that'd be fantastic for what we're doing, because we have the ability to make, hundreds of variations here, looking for something even more optimum on tensile properties. And also the other thing is materials. I think it relates to a lot of the applications here. They're actually quite complex in the sense that, like, in our stuffs are all nano composites, and they're a little bit different than what you're used to on a bigger scale. And you never can quite predict what's going to happen. And then in terms of its application, batteries are very complicated, but you can't get a final read on what you have until you get it into a battery bed. Obviously, you want to make sure you have the mechanical strength that you want. So I think what I'm basically saying is it's a lot easier to collaborate when, like, the one company like us has got a good, strong, basic, broad platform, but they're really trying to optimize and get the commercial product, and other people have the means to do the accelerated testing. That's very interesting to us. Or you have somebody like the hydrogen membrane. We're very interested in that area. And we have this sister company that's in England that can put any material on any substrate, including all the different metals. It just kind of set up for collaboration. So it's kind of that situation. You really got to get the patent part straight. We don't mind working with people, and then their inventions come out of it, and whoever invented it deserves to get, participate type of thing. But I think it's real tough to collaborate if the IP stuff is kind of unformed, and then you're going to be doing all these things. So it helps to have a little bit of pre-work before you get into these collaborations. But we're very open to collaboration, and we can be very open on our technology because it's all described in patents.
Yeah, that's great. And one of the things, Stephen, I'll mention is that we are thinking very deeply about IP and how we protect IP of the companies so that they can actually take them to market. And I'll just say that we're aware of that kind of stuff and paying close attention to how we develop it, so it's a win-win. Makes total sense. And I know one of the areas that we're looking to support within MAPS is the electrochemical side in a very, very strong way. Partly because it actually can be done in an automated fashion reasonably well. And so I think that that's good. And what about just expertise development, the ability to train, the access to people and the development of people in a center that's got a broad diversity of equipment? Stephen, what would that do for you, for instance, if you had access to the foundational expertise rather than the IP related stuff, the foundational platform development, to be able to deliver the kind of projects you want so that your people can think independently and creatively?
Well, that would be very helpful to have some of these newer approaches in addition. The other thing that for example, to our company, we want people to spend like 15% of their time just on exploratory things, with not on our set projects. And we also remind everybody to ideas come to them a lot of times, they're meant to be tried out, but these advanced development techniques are very suitable for people like ourselves. We have like a platform we've been working on for actually about 25 years. And so we can take our kind of empirical knowledge from all that work we've done and also we know the application side really well. And you can really, it would be really interesting to sit down with some of these groups and apply the advanced development methods to an area where we have a lot of know-how, but we'd like to, really explore finding better materials. I mean, as I said before, it's my experience, and I can, I won't give you miles of examples of it, but my experience is usually the best materials win. So it's all about finding better materials, and they're fairly complex situations. The other thing that relates to these collaborations is it's like everything. You really want it to be win-win, so that also it'll help the people with the advanced development techniques to refine what they're doing and to be better at it and to adapt it for certain industries. So I think I have people working for me that have 30, 40 years of experience in the kinds of things we're doing. And so if we could work with people that are into the advanced techniques, they could really be a really good collaboration on how the advanced methods could be applied to these areas we know well. So that's, it's kind of like different styles of R&D coming together and get the best of both worlds. I think that's my basic point, is you really want to do a hybrid here. You want the individual creativity and all the basic homework about making sure you do your IP part. Also, you got to have freedom to practice in this world. You got to eventually, you can't develop something that someone else has already patented, types of things. I've seen that happen a lot of times. One last comment. I've been actually a U.S. registered patent agent for 28 years, and I've just done everything in patents just as a kind of a supplement to my regular job as a CTO, and sometimes I've been head of marketing. And even when I just sold my company to Meta Materials 9 months ago. So for 21 years, we were doing the same struggle that startup companies do. And mostly self-funding ourselves different ways. And one of the ways I self-funded myself is be a patent expert in patent litigations. 10% of my time I could make my salary and not have to take a salary from my company. But the point is, we're always happy even to collaborate with people on best practices for the IP part, just because these are things that take a while to learn. And if you don't do that right, you're going to be sorry later on. But yeah, I'm really fascinated by these different examples, like the cube with the automatic tested, because that could accelerate our development. If yet our people know our particular applications, we would be able to help do the automation part just from years of experience doing it basically manually, type of thing.
Thanks for that, Stephen. Curtis, I wanted to jump back just quickly. During Project Ada, you developed skills and very diverse skills in the people that were working, your grad students, your postdocs, and they had to learn quite the hard way, all the integration, all the controls. One of the things that we focused on was getting a mechatronics team together to support a broad set of maps. If you had that, is that something that would have maybe accelerated even your work? But moving forward, you talked about CO2, hydrogen, batteries, and we know the importance of computation. What are those kinds of foundational things that would help you in the future so that you don't have to do that work itself on the platforms? And I benefited from the session that we're having here. So emission innovation, materials for energy workshops and symposium this week. And this is just a part of it. And yesterday we heard from the delegation from India about the IC maps and the maps that are being deployed in India. And one of the things that I noticed is that they also have work in the area of AI ML. And what they did was that they put a team together to support the different topics of the IC maps. There's 3 main pillars, and I won't go into detail, But the fact that a center that provides specialized support to AI ML, maybe a higher level question, and I want to go because I want to find out what is needed from our government partners. The engagement, we find hubs. We have a critical minerals hub, we have a hydrogen hub. What is it that we need coordinated at a higher level, at a hub level? And Stephen, you're newer to this, but what do you see with what we're trying to do on the accelerated side that could benefit your organization or organizations like you? And then I'll go to Curtis because I'd like to have some input on that as well. Is there a hub support, a higher level hub, not the technical side of mechatronics, et cetera? What do we need to do to get organized there to engage you better?
Well, I mean, that's a good question. I'm only finding out now about this accelerated materials development. Like I know in the battery business, as I mentioned, Wildcat Discoveries has been doing a version of what you're talking about. And of course, being a lifelong technical person, I totally appreciate the efficiencies and what you're doing there. So just finding out about your organization is a huge progress for us being able to do things in this area. And so I have a general picture now. I don't know the details of exactly what they're doing, but for example, what Caleb presented on the cube, as I mentioned before, doing those tensile tests, that's something that we might be able to utilize, and it'd be interesting to talk about it. And I don't know if your central facility is doing anything quite like that. Also, another comment is we have like 7 different product verticals. I'm just representing 2 of them, which are, the metallizing group that's doing the plasma deposition. That's pretty unique. And then also the porous membranes that we make for the battery separators. But we have some really good experts at AI. What they're doing is they're designing transparent conductive films, and where we have very, very thin, like 400 nanometer wide metal lines, and they're doing it to stop different radio frequencies and that. But I'm just saying, we have a group, several people who are very talented in AI, and they're also very good at modeling. So that's something that's not inside my group right now, but that's a group that we could work with and interact with your government labs. And of course, we are a Canadian centered company, although we have these satellite operations in the US. And so that's my basic reaction, just learning that you have this activity, and it's certainly fits our type of R&D work. So I'd be interested to explore it with your government operations and also with some of the speakers today.
I heard 2 things there in the answer to that question. And Stephen, you talked about just being aware, and we knew you were coming in as newer to the MAPS world or ecosystem, but that's the purpose of that, was to highlight that there's many, many more companies. They could be SMEs, they could be startups, they could be multinationals, and they really do need to know, at least be aware. And then Curtis, the fast access is another really good response. We are hopeful that we'll make the new facility highly collaborative, which means you'll have people in there on the ground as they need to be trained or as they need to run campaigns. And so it's an important part of it. If they're already integrated, access becomes a simpler step, I believe. And so that collaboration, the way we design the collaborations, I think is going to be important. I wanted to jump back because along the way, we talked about CO2. We talked about hydrogen. We talked about batteries. We also talked about computation. And Jennifer and Andrew, where do these fit in our priorities? And what do you see in terms of us being able to support the kinds of things around this? What do we have that we're working on, or what is our mandate that allows us to engage in this area as well as the acceleration?
Well, we might want to do this in a bit of a mixed fashion, but I'll let Jennifer jump in perhaps with specifics if necessary, but the so specifically we've got, we mentioned the funding side, of course, so we have funding support for some things. We still have some, some level of funding support in hydrogen development, and green hydrogen, some level of CO2 conversion to fuels, and of course all the materials associated with that. We are developing, we have a program called AI for Design, which actually supports funding of AI tools for materials discovery, amongst other things. We also, one thing to mention is the, which is just about to get, hopefully, Treasury Board final approval, is our critical battery minerals initiative, which is going to be a 4-year NRC program that is going to be focused on materials discovery relating to the batteries, lithium-ion, other chemistries, but not solid state, and also transformation of battery materials, whether it's recycling or from ores. And so those are going to be areas where there will be some level of financial support. But I should mention also that in the case of NRC, we don't look at these as primarily funding support. We look at these as NRC is developing capacity in those specific areas in the new facility, right? So we will continue to expand our development. And the work in hydrogen is primarily and CO2 conversion, primarily electrochemistry, electrochemical cells. And so we will have to work closely with folks like UBC and UFT to make sure that we put in place the right capabilities so that they're not duplicative, but they're foundational, that can be deployed quickly to support discovery and development and optimization of a lot of the different material related to electrochemical CO2 conversion and hydrogen generation. And of course, I'm not entirely sure what the maps will look like in the critical battery material space. We're still very early in that, but we will be establishing at least a couple of maps, is the concept in this saga, which will support Canadian development in that early mid, after you mine and extract and do the initial processing before you assemble your battery, some of that midstream space of critical minerals batteries.
And I think a lot of what's been said is about capacity development. So maybe there's not project funding today, but we're getting a higher visibility in governments. The CPREP, the $200 million CPREP is a good example of that there's greater visibility on accelerated materials discovery. But what government is doing through the critical minerals file, through the hydrogen related activities, the hydrogen strategy, is to develop capacity. I think that's a really important thing. The more we understand what the companies need, the better we can build the right capacity to support it. And Curtis, as you said, whether it's CO2 conversion or hydrogen production or Stephen, as you said, batteries, we have to be able to get the capacity in that area. Jennifer, did you have anything to add on sort of the capacity side, the mandate side, the drivers behind things?
Sure, thank you very much. And thanks, Andrew, for your really fulsome description of the new program for critical minerals. The National Research Council of Canada, being an instrument of the federal government of Canada, reflects the priorities of Canadians, which is increasingly towards climate change and sustainability. And some of the new interests and programming of National Research Council research will be turning to climate change. In particular, in the federal budget in 2022, there was budget allocation to revamp Canada's building code. And there will be 2 new programs at the NRC that will focus on two aspects. One aspect is next generation building materials. So industry-led new materials for building and infrastructure construction. And the other program will be focusing on revamping the Canadian Building Code and also digitization of the construction industry and also looking at performance-based codes. So those two directions will be reflected in new programs at the NRC that are under development. And I certainly don't want to speak for the program directors, but one could imagine that these new platforms and new materials and developments towards more environmentally friendly building and infrastructure could be very interesting for this audience, and perhaps accelerated materials development could find a place in those programs.
Just jump in quick to add to that a bit. One of the things that we're trying to do in Mississauga, and this will be driven by my colleagues who run the lab, would be to position Mississauga as a bit of a hub within NRC for accelerated materials discovery, to introduce this concept to the broader National Research Council, including our colleagues in the construction space. And so we're going to actually try to draw as much as possible on the full spectrum of capabilities in NRC, which are rather bigger than energy materials. And so it's the catalysts and et cetera, we're focusing on the battery materials. So with time, we're trying to bring this capacity in that space and have it so that you don't have to go to the Construction Research Center to access that. You do it through Mississauga, and we support them. So we're trying to do this in multiple different dimensions at once, for the industry, and of course even drive this discovery paradigm throughout the National Research Council itself.
Yeah, that's great. And Jennifer, one of the things that I wanted to ask you specifically, you mentioned the 5th year German-Canadian celebration that was back just a few years ago. You also said that I guess it was Jason Myers that said that the S&T meeting between Germany and Canada is happening very soon. And the international file, obviously you're located in Europe, you're located in Germany, and the international file is potentially going to change with Canada and its foray into joining the European Commission to allow greater international collaboration. And there's been discussions about supporting those kinds of things. Can you give us some insights on how important that international collaboration is from your perspective?
Yeah, thank you. Good question. I think there's a lot of willingness internationally, particularly at federal levels, that support or that actually pay for infrastructure to increasingly work together to leverage the very expensive research infrastructure. And examples are high performance computing. And at NRC also we have infrastructure like wind tunnels. And actually I have a colleague with me from the DLR, the NRC and German Aerospace Center work very closely, increasingly sharing this kind of infrastructure. And I think as time goes on, these new materials acceleration platforms is an example of where there's a willingness to avoid duplication and to work together. I can't really comment on Canada's participation or the state of the negotiation for Canada joining the EU Horizon or these programs, but to say that there is a great deal of willingness to collaborate. Canada and Germany enjoy a cultural similarity that I think is very beneficial for the results of our collaborations. And I think there's a willingness for Canada and Germany to maybe be some leaders in a broader Canada-European collaboration. So I think it's seen as very positive, and we're hoping for some really positive results in the near future or announcements that would support even deeper or longer term collaboration.
Yeah, thank you for that. Curtis, I was gonna just jump to you, but I'll go to Stephen. And what I have is a question around the international collaboration. Let's face it, what we're doing is science that can't be done by a single entity or single country. And you've known that all the way along, and that's why Mission Innovation started this originally. And Stephen, for you, how important is getting access to the international community? And how can we help with that? And then I'll ask Curtis that same question because he has actual collaborations there.
Okay, well, I was going to mention, like with Germany, our key, the company that supplies the aluminum oxides we use is Sasol, which has a big operation in Germany and Hamburg, and also they have a big operation in the US in Louisiana. And you know, we could be doing a lot more collaboration with them on optimizing. You know, we basically treat their materials in a lot of different ways, as well as processing. And then obviously, since we're in the battery components business, we're working with several of the really big German EV companies, and to give you kind of the final, you know, kind of confirmation of the value of what you're doing. As far as the international, we've been always, you know, I mean, the battery business is mostly in Asia, so we've been all over Asia. And so forth. So we have all those contacts already, and that could be useful to people, you know, working with people in Canada and in Germany. We know lots of people in Korea, lots of people in Japan, and we've been to, I've been to China 6 or 7 times and so forth. So we have a lot of connections ourselves. I think what we're talking about here is actually where can we do some projects where there's a lot of win-win-win-win type things, and end up with a good result that, you know, towards our goals. And I certainly would like to participate in trying to find those win-win situations with companies kind of internationally, in terms of, you know, there's fantastic. Like in the battery area, there are many research institutes in Germany that are just fantastic and great. And, you know, we know some of the professors there and so forth, but we don't really have an active collaboration going with any of them. We're more like working right now, collaborating with one university near us in Massachusetts, because they actually have a really good coating machine to make our separator, which is, you usually don't find that at a university. But yeah, there's a lot more room for collaboration. And I think this is where the government has some ability to help pull these parties together, because they have certain initiatives. And one example is that, you know, in the battery business, number one thing is safety. So that's a whole different story. And then the second thing is low cost. They really got to take the batteries down another 40% in cost. And, you know, we have some of our technology relates to doing those things. And that's something I think the governments are in support of. And we certainly would be interested to get engaged in collaborating between the government and industry and in several different countries, Canada, Germany, to see if we can come up with a project that we all want to work on that. And some of it, you know, one of our ideas is one of the materials, lower cost materials that are out there, that we can adapt that to put that into our separator. That's about as inexpensive as a material could be. Those kinds of things. We also, our focus is really battery products, but we do have some interest in like a Nafion membrane replacement, which is something was brought up earlier. We won't divert from our focus right now, but we have technology that could lend itself to work in that direction also. We stay very focused, though. I think it's from the other speakers, you can tell you have a goal. It's like Curtis said, you got to get to this goal quickly this world is moving fast. And so you won't divert off into some that you probably could do, but it's going to take you 2 to 3 years to get really momentum on it. We're trying to finish the stuff we've been working on it. But yeah, we're very interested to participate with people that want to go after certain objectives. And the one other thing that we have that's not apparent by just looking at us, we also have lots of patents on different ways to put the battery together, to change the order that you do things and so forth. And this can be advanced manufacturing of the batteries themselves, including digital printing and so forth. So, you know, we have a lot of flexibility in our technology platforms, but we'd be open to, you know, collaborating with people in working in some of those areas. Right now, we're just basically making the separator component and working with the Plasma Apps group in Oxford, UK on current collectors. But we actually have a lot more that could be tapped if we could get some kind of international collaboration on it.
Okay, yeah, thanks for that. It's really important. One of the questions I was going to ask is that are there places that you could apply accelerated materials discovery? I understood the answer to that question ahead of time, but it's nice to hear it from you instead of me. That's all. It's useful because it reinforces the things. And if we can bring together in a center, perhaps a centralized place, that international community to support you locally, that might be a better thing as well. Angela suggested that there's a question from Michael Boydus. Michael, did you want to come on screen or do we have the question?
Yeah, it looks like Michael's actually.
Oh, Michael, go ahead, please.
Yeah, thank you for yielding the floor. Good to see you all, and thank you for the absolutely great discussion so far. So I'm professor of chemistry and innovation and policy consultant here with a German Jura. And I would just like to bring in a couple of considerations from a political and legislative perspective. So we are currently working with a German Institute for Standardization, the Dean, on the ISO Project Committee, Sustainable Raw Materials. And the ISO PC, Sustainable Raw Materials, aims to bring together the EU's Critical Raw Materials Act that passed in March 2023 and the ESG criteria as stated by the G7 and G20. And one of the core ideas that is being developed there is that of a digital product pass. Yeah? This product pass would allow for traceability of CRMs in our increasingly circular economies. And what I see here is the unique concept of MAPS, that means accelerated materials discovery, analysis, and AI-assisted interoperability of data would facilitate the implementation of a useful digital product pass. And I believe we are at a very critical moment in time, and that GCMAC offers a unique place for us to think about the relevant KPIs for compliance with this political agenda ahead of the curve, and for us to set standards and good practices that are useful for German and Canadian companies and partners. So my question, which I already forgot in the chat a little bit, to what extent would you see that MACs would help to future-proof businesses, and B, would support the implementation of meaningful and useful digital product passes, or in fact, data repositories that are fair? That means findable, accessible, interoperable, and reusable. Thank you.
That's a very interesting question. So in a nutshell, to future-proof business, given the changing landscape, rapidly changing landscape, if I could ask, does anybody have any thoughts?
Maybe perhaps I could say a couple of words about that. National Research Council of Canada is also responsible for the National Measurement Institute in Canada, and I recognize that some of our staff are involved in some of these standardization activities. So I think there is some of that going on in Canada, and the NRC as a convener in Canada is likely connected to other Canadians who are participating, and likely connected to the German stakeholders, such as the PTB and you mentioned ISO standards and so forth. So absolutely, I think that's an area that perhaps also needs to be accelerated in order for our industry to stay ahead of the curve. And I would be happy to facilitate introductions or connections in that regard. But I believe that's an area where NRC is working from a standards perspective. I think if I take off my NRC hat for a moment, I would say that's also standardization is an area where governments typically participate, as you mentioned, the Dean in Germany and governments participate in the ISO. But I think what's really needed a lot of times is industry participation also, so that the standards that are developed reflect what an industry requires. I think in this instance for maps and we've been talking about batteries and so forth, I think NRC and NRCan have some kind of perspective about what industry needs are through the collaborations. But at the end of the day, we really need industry to come to the table to develop these standards so that they are actually, you mentioned the word fair in the context of usability. So that would be my comment on that. But I'm happy to make any introductions that could expedite Canada, Germany, and working in this area.
That's great. Thanks very much, Jennifer. Future-proof business, Stephen, Curtis, any thoughts there? One thing that comes to mind as well, and when you talked about data, we had a really good discussion and the standards themselves, but data and data ontologies. Yesterday, we had a session where we learned more about what a data ontology is and how to get good high fidelity data, which is needed in a map, by the way. And that data, the data and the data ontologies is something that the European project Big Map focuses a great deal on. But we learned a little bit more about why we focus on data ontologies. It's so that we can actually train AI algorithms to understand exactly what the data means and how it links to things. And that's kindly provided by a talk from Ola Lovik from Sintef in Norway. And so it extends beyond standards itself. It extends to the data fidelity that we can get from maps and the ontologies to be able to build systems that respond to the computational predictions that we have. And so when you're looking for those new materials that don't rely on iridium and platinum and expensive items that we have to be very careful with, scarce resources, and move to earth abundant, low cost materials to solve various problems. We're gonna dig deeply into those data and data ontology systems to be able to do it. So I'll open the floor further to questions. I'm wondering if there's any questions or comments from Khaled. You've been listening now for a little while to a lot of things. You see where people are in the early stages, etc. Is there any comments from you? Do we have any questions on the floor? Put it in the chat that you'd like to ask a question if you have. Any comments? Go ahead.
Yeah, I think you're. Oh, I think so.
Actually, I think Mark kind of got my idea, and so.
Oh, okay. Sorry about that.
Okay.
Yeah.
In terms of the new facility, I think you guys are building on Saga and the resources. When I look at it, it's a zero start problem, right? Like when you have an idea for a map or a customer comes along, or there's an industry need around how can I accelerate the process. Problem is for most SMEs and companies, I find is they obviously don't have that multidisciplinary expertise, so they don't have the AI piece, or they might not have the mechatronics piece fully or whatever. So I think having a resource such as what you guys are building out, where that can be the start of the project, you can prove it out, you can build a proof point from it, and then from that, I would then hire the team to take it and build on that project. I think that's the best use, or at least for us, in terms of how I've been looking at it. That would be an amazing use to get us to something that we can commercialize faster. Right. So that's kind of the way I've looked at some of the resources that already exist. So instead of having to all of a sudden have hire another mechatronic person, an AI person, whatever it is, I can utilize some of the resources that exist and people that are experts around maps. Build out something prototype or whatever, and then that gets you that first step. And then you can then look at how to commercialize and who is needed as part of that project. Have that knowledge transfer from the people that would be at the NRC to the building, your company or whatever, and then you can take it to that project. That's kind of the way that I see the progression, or how we look at using the systems that might exist when they exist. Because otherwise, I mean, I think Curtis alluded to this, it takes years to find funding. And that funding, you need to hire people, and then it takes a long time to hire people and ramp them up and look good. So it's just, the whole process is very lengthy if we're gonna do it the normal route.
So to the point of fast access,
Yes,
foundational support to maps, the mechatronics, the AI support, that kind of stuff, make sure it's clean and available. Okay, that's interesting. I have another question, and Canada's a big country. We're gonna have a center that we've developed, we're building. Center going by the needs of the broader big country, and for that matter, if we're solving these things in an international way, is that center one of the centers that will support the entire country? And or do we need more of these across Canada and internationally that really focus in on the foundational aspects? Anybody? Any thoughts? Do we need another center close to the west? Kind of looked at that and thought maybe that's one of the possibilities. So I thought I wanted to have it stated. The other thing is that we should look around to see if there's other places that could support industrial activity in a more regional way as we move forward. And so that's just one example of them, and I think that that's really important. Any other questions out there? I don't see it on anything on the chat. Any other comments from any of the speakers that we have on? Ira, I believe you're probably still there. Are there any insights that you have or comments that you have as well? I didn't want to lose sight of the fact that we had you and Khaled involved in the stimulus talks.
Yeah, thanks for that, Mark. I think one of the takeaways was a comment by Curtis about the importance of having a functional device at the end of the day. MAP has certainly got great predictive capabilities. It certainly has an ability to go where, let's say, where materials haven't gone before. But the acid test is still about getting enough confidence to go into the marketplace, having got some hours under the hood of the car, of the device. That's a particular concern of BC Research in its piloting and trying to bridge the gap between the benchtop and industry application. And a lot of our focus is on having real life applications or in situ demonstrations that can validate what comes out of the benchtop experiments.
That's great. Thanks for that. Going back to Yulish, Michael, I think with where we are right now, there's no additional questions. Nobody's raised their hand to ask a few more things. At this point, I think we'll close the panel discussion and the open questions, and we'll thank very much the speakers, the panelists, and the people that have joined us online. We really appreciate the effort to join, especially the ones that are coming in from early in the morning on the West Coast. We know that that's sometimes a challenge. So thanks very much for that. Michael, do you want to have a few words to tell us what you heard from the Canadian side?
Sure. First of all, thank you also. Thanks all the speakers, all the panelists for a very intriguing discussion and many valuable contributions. So I think there are certain aspects that we'll pick up again tomorrow. So we'll continue the session and have further discussions, in particular, maybe focusing a bit more on the integration aspects. So today was very much focusing on the maps and building infrastructure. And yeah, well, I'm looking forward to having the continued discussion tomorrow. I mean, what I found particularly interesting was what Curtis said about, let's say, the competence that is needed, the aggregated competence, and that has to be readily available, right? If someone has an interest in, let's say, building certain self-driving lab infrastructure, maybe maps, maybe something that, let's say, goes more into the direction of technology development. So let's say, what kind of hub do you need actually? So what kind of competence should be aggregated? It shouldn't be too, let's say, broad. It should not be too specialized at the same time as well, right? So you need to have people who have, let's say, the methodical background to help build, let's say, the data analytics tools and bring in the AI aspects into that. At the same time, they also need to be able to interface with the experts on the domain side that have the specific, let's say, domain expertise on the batteries, on the fuel cells, on the electrolysis cells, and so on, right? So I think that needs some further consideration. I mean, how such a supporting infrastructure could look like, that to me would be a very interesting aspect to discuss further.
Michael, one of the things that we wanted to do was to give examples today. Tomorrow, is that the industrial researchers have an opportunity to get involved and have discussions and look for opportunities with our teams. And I think that's one of the reasons that we progressed from understanding examples of maps to the actual integration tomorrow and the themes that we presented earlier. So with that, I think we'll close the session. Thank everybody for participating with all the information that was shared, and look forward to starting tomorrow morning, tomorrow afternoon in Germany with the day 2 of GCMAC's Industry Days. Thanks very much, everyone. Have a great day.
Thank you very much. Bye-bye.
Bye.
See you tomorrow.